This is going to be a brief video lesson of section 7.5, which is titled Solve Special Types of Linear Systems. 7.5 builds up on everything else we've done in chapter 7 so far. It includes a little bit of solving by graphing, a little bit of solving by substitutions, and eliminations. So it's kind of like a culmination of what we've done so far. Now, as we've worked through chapter 7, we've been solving systems of linear equations, and we almost always get a solution that is an ordered pair, which is the intersection point of those two linear equations. Now, there are some rare cases or exceptions. There's two of these exceptions, and we're going to talk about them. But the first one is where there is no solution to a certain system, and I'll show you how that looks both graphically and through elimination. And the second case is where there is an infinite number of solutions to a given system, and I'll show you both of those as well through graphing, and for the second one through substitution. So let's take a look first at a system which is very similar to any other system we've seen so far. That's a 2, sorry. So pretty similar pair of linear equations in a system. We've done these many times, the second semester. So looking at this, you can probably eliminate this very, very easily. But before we do that, let's look at it graphically, because if you remember, we can graph all of these systems just fine. We don't have to use elimination or substitution. Graphing is always an option. But let's try the graphing method. To graph these equations, you need to put them in, well, you don't have to, but the easiest way is to put them in slope-intercept form, which is y equals mx plus b. So you want to solve for y in both cases. For the top equation, I'm going to subtract 3x from both sides, and if you do that, you'll get 2y equals 10 minus 3x. So I'm just subtracting 3x from both sides. Then I'm going to divide both sides by 2 to get rid of that 2 here. And 10 divided by 2 is 5 minus 3 over 2 x. Okay, slope-intercept form, with the negative 3 over 2 being the slope and the 5 being the y-intercept. Let's do the same thing for the bottom equation. Again, I'm going to first subtract the 3x from both sides to get rid of that, which gives me 2y equals to 2 minus 3x. And then I'm going to divide everything by a 2 to get rid of this 2 right here if it's being multiplied. So I'm going to divide. 2 divided by 2 is 1. And then minus 3 over 2x. So looking at the two equations, you should right away notice they have something in common. Specifically, the slope they have in common. If you remember from chapter 5, I think it was, when we were graphing, we learned that if two equations have the same slope, then they are parallel to each other. So let's just say this does not necessarily have to be these two equations, but just to show you visually. So these two are parallel. Okay, I'm not sure if this is representative, but just to give you an example. These are parallel equations. Parallel lines do not ever touch. This is what makes them parallel. To get a solution between equations, we need a point of intersection. So if they never touch, they will never intersect, and they will never give you a solution. So if you solve these through graphing, you don't actually have to go through and graph them out. As soon as you see that they have an identical slope, you know they're parallel. Parallel lines cannot intersect, cannot give you a point of intersection. There can be no solution. So this is considered a no solution type of a problem. There can be no solutions to this system. Let me do the same problem through elimination. So instead of the graphing method, we can work this through elimination. It's actually very simple. I'm going to choose to subtract the two equations from each other. 3x minus 3x, 0. 2y minus 2y, 0. 10 minus 2, 8. 0 plus 0, 0 still. And 0 is not equal to 8. No solution. So we came to the same conclusion as we did graphically. There is no solution to this particular system. Now I could have also used substitution. That was probably going to be the messiest of the three methods for this particular problem to solve it, but I would get to the same outcome, that there is no solution, if I tried that approach as well. So again, if you encounter a system and you solve it graphically and you get an identical slope, or if you solve it through either substitution or elimination, you get something like this, where you have one number not equal to another, like 5 equals to 10, or negative 3 equal to 6. When you have on either side of the equation, you have different numbers. That's a no solution for you. That's one of the exceptions. The second exception to what we've been doing is infinite many solutions. So I'll show you what that looks like in just a second. So again, we're going to have a system of linear equations. In this case, it's x minus 2y equals to negative 4, and y equals to 1/2 x plus 2. Now, just like before, you can do this graphically, so let's actually graph these out and see what we get. Now, in order again to graph, the preferable method is through slope-intercept form, so let's do that. The second equation is already in slope-intercept form, so let me go ahead and put the first equation in slope-intercept form. So to do that, I need to isolate y, which means I'm going to get rid of this x first by subtracting x from both sides. When I do that, I get 2y equals to negative 4 minus x. I subtracted x from both sides. Then I'm going to divide everything by a negative 2 to get rid of this negative 2. It's being multiplied. I'm going to divide. So y equals to negative 4 divided by negative 2, which is 2. And negative x divided by, or remember there is a 1 coefficient here, so essentially it's negative 1 divided by a negative 2, which is 1 over 2. Positive 1 over 2 x. Now take a look at these two. You can always flip these two around. They're the same thing. Y equals to essentially half x plus 2, or 2 plus 1/2 x. It's the same equation. It's the same line. If it's the same line, let me show you through graphing what it would look like if we were to graph this. It would look like something like this. Because it's the same line, they're going to be lying right on top of each other. There's no variance, which means they'll touch at every single point that there is. And every time they touch, it's a solution. So because they're touching at every single point, and it's an open-ended graph, there are infinite solutions to this particular system. So through graphing, if you put them both in slope-intercept form, and it's the same, I mean this in this form and this equation, they're identical. So that means these two are identical, and if there are two identical equations, that means when you graph them, it's going to be the same line, infinite many solutions. Now let's do this through another method. We already did elimination with the previous problem, so let's work with substitution. I'm going to substitute one variable for another. Y is already solved for me here, so I'm going to substitute that y in for the y here. So x minus then I'm going to distribute the negative 2 to every member of the parenthesis. So it's going to be negative x, because negative 2 times a positive half, that's -1. I don't write the -1, so negative x. -2 times a positive 2, it's -4, so -4 equals to -4. X minus x, that's a 0. -4 equals to -4, and -4 does indeed equal to -4. And this is what an outcome of an infinite solution looks like. You have two numbers that are equal to each other, because no matter what you plug in for the x and the y, you're always going to have the same number being equal to each other. Every solution will work. Infinite many solutions. So again, we did it through graphing, and at least partially, and we did it through substitution. This one you could have done with elimination as well. It wouldn't really matter, and you would essentially get to the same outcome. You might not get -4 equals to -4. You might get 0 equals to 0. It doesn't matter. Every single point will work for this particular equation. You can get 5 equals to 5, 6 equals to 6, 100 equals to 100. Infinite many solutions. It's going to look like this every time if it's an infinite many solutions, as opposed to looking like this, where two numbers that aren't equal to each other for no solutions. So that's the difference between two no solutions. You'll have two numbers that are not equal to each other and parallel lines. In infinite many solutions, it's the same line, just typically written in a different way. And if you solve it through substitution or elimination, you get the same number equal to each other. So that is infinite many solutions. So easy to spot between the two. If they are on top of each other, or if the outcome of the substitution or elimination is the same number being equal to each other, infinite. If they're parallel, and if the outcome of the elimination or the substitution is two numbers that are not equal to each other, no solution. So let me write that down. No solution. And this one is infinitely many solutions. Alright, so that was it for the brief lesson for 7.5. I'm going to work out two problems from your homework in the next video, so please look at that as well. And best of luck. I'll see you back in class.